Okay, so I'm going to share with you some, a work in progress regarding the connection between water, food, and poverty, mostly based in Colombia, because this work is in collaboration with the National University of Colombia, and we start from, by looking at the literature, we can see that it has been a development regarding the so-called concept of footprint. So from at the beginning, from the ecological footprint, it has been extended to water, CO2, and they developed the concept of footprint family. So try to put together more than one natural footprint. And also it has been extended to social footprint. So try to evaluate the indirect effect regarding production in terms of income inequality, bad labor, and so on and so forth. However, still few works have been done trying to connect these two dimensions, so the social economic one and the natural one. And so there are few attempts to try to fill the gap, to put a bridge between these dimensions. In our case, our main motivation starts from the considering that if you look at the Colombian GDP, it is still a fifth than the US one. So we are asking if there are local limits to the attainment of the so-called sustainable development goals that also include, the idea is it possible that all the so-called developing countries, let's say poorest countries, can attain together the social economic development within the natural limits, or there are some trade-offs that can emerge? And in a previous study that is being published in a book that I recently edited, we found that if we look at the lower scale, and so at the regional and department level, we found that there are some water abundant and some water scarce regions, although Colombia has a lot of water, so it is considered a water abundant country at aggregate level. And moreover, the poorest, there are a lot of poor people that have no access to clean and safe water, and that is not compensable with the so-called virtual water, so the water embedded in the goods that are imported from abroad. So we are trying to go in this direction to try to evaluate the connection between the socioeconomic side and the natural side and the possibility to attain the sustainable development goals. And for this purpose, I want to make an example of the systemic thinking, so the way in which we are going to think about this problem. So let's start with SDG 8, that is economic growth and decent work. And so if we want to have a green growth, we have to attain to we have to make use of clean energy. So SDG 8 is connected with SDG 7, but to make clean energy, most of the time it has been proposed to use like maize or this crop to produce energy, but the crop have effect on poverty, so people that are depending on this kind of products, on land use and on water use. But water use is also affect the climate with the hydrocycle. It affects, climate, and the climate affect the availability of water, and the climate also affect land. And so maybe if we make too much use, and with the deforestation and so on and so forth, it may emerge a pandemic that also have effect on climate and economic growth as well. So it is only an example to show that all these dimensions that are treated separately in the SDGs actually are connected. So how to study and what kind of methodology we are going to use to study the complexity, and so the interrelation between these dimensions, we are going to use the input-output. So we have, in this case, for Colombia, we have more than one department. In each department, there are several economic sectors and the final demand by households and government. and the international trade with the rest of the world. So black arrows indicate the intermediate trade across the sectors within the same department, while the dotted line is the trade, so the final consumption within the same department, while blue arrows indicate the trade across sectors and across department. So, for instance, Department A is selling to Department B, and the dotted blue line is the how much a sector is selling to the final consumers in another department. And green line is the international trade, so the exports from the sectors to the rest of the world, but we have no information if they are going to be used by the sectors or their final users, while the red lines indicate the imports, so the imports from the industries and the import for the final demand. But also we have data regarding the water and the labor that are linked with the production process, so as an input, but also, and labor also as an input, but also as an output in terms of social effects. So how do we translate? I will go a bit fast here because otherwise I don't have time to show the results. I mean, here we are going to distinguish between the domestic trade, but we are going at a lower scale. So not only the trade, so the trade within Colombia is disentangled across, disentangled by the trade across departments. And so this is a necessity to evaluate the local effect, the local impact. And moreover, within each department, we have more than one sector, as we will see. And so it's a way to evaluate also at this scale. With the input-output, we are able to distinguish between the direct water effect. So this is the virtual water trade. So this is simply the application of the water intensity coefficients to the matrix of intermediate trade, but also the total water intensity index. That is, the water intensity multiplied by the Leontief inverse. The Leontief inverse is the matrix that solves this equation that you can see here, and it is used to capture both the direct and the indirect effect from a change in the final demand. To make an example, if, for instance, the energy sectors face an increase of 10% of final demand, it is not only the energy sector is affected, but all the other sectors that are buying and selling to the energy sector. So this is, so a 10% change in the final demand of the energy sector determines a change in all the other demand and supply of the other sectors, and in this case also in the other departments. So to compute the water footprint, we distinguish between two parts. So the first one is the Colombian domestic trade. So by evaluating the impact from one department to another department, and the international trade. I don't go into the details for the formula. So the results that we are going to show is they are mostly based on water because we are still working on the socioeconomic side. However, we want to show the virtual water trade, so the direct effect, the total water footprint, and a spatial visualization of the water footprint. And we also showed a map of informal labor rate by sector and by department. However, we have data for other socioeconomic index. And we evaluate 8 macro sectors. Most of them are related to food, so agriculture, coffee, animal, forestry, fish, and processed food. And we have this kind of spatial disaggregation. So we have 6 macro regions and 33 departments. And so we allocated these departments to the 6 regions. However, we have, till now, we have data only for 1 year, that is 2015. However, we are going to work to extend the database. So first of all, this is the virtual water trade. This is the core. So the 80% of the total flow that collect most of the trade. And the color means the region. So the first three letters are the region. So for instance, Caribe, Andina, Orinoquia, and so on and so forth. And the other are the sector. So for instance, in this case, it's Caribe agriculture sector that is selling things, and so it is indirectly selling the water needed to produce the product. As we can see here, we can see that most of the virtual water trade is concentrated within Colombia, while the black lines that are related to the rest of the world, so the imports, are lower in number and also in volumes. While Bogota is very interesting because I mean, it's the capital city with almost 8 million people, and it is only receiving Bogota mostly receiving water from all the other sectors and region, mostly for the food process. So it receives raw products, and by manufacturing the manufacturing sector is going to process. So it shows the dependency of Bogota by the water of the other regions. Here we have the total water footprint on the left. So we focus on three departments, that is Antioquia, Bogota, and Casanare, and we'll see why. Why on the right, it is all the components that are included in the water footprint. So the dark blue is the water footprint related to the consumption within the same department. So Antioquia, the amount of water that Antioquia is using within Antioquia itself. While the orange is the amount of water that is sell to other that comes from the other department. The violet is from abroad for intermediate goods, and the green is from abroad for final consumption. While the yellow and the light blue is the amount of water that is exported, either to the other departments, so within Colombia, or to rest of the world. So these are negative values. Here we show we compare the net water footprint across the departments, so within Colombia and with the respect of the rest of the world. So by including the international trade. So it means that, for instance, if we look at Bogota, it is on the first quadrant that has both positive values. It means that it's a net importer of water with respect to the other departments, and it is a net importer of water with respect to the rest of the world. However, if we look at the values, we see that the amount of water that Bogota is importing from the other department is much more greater than from abroad. And it is true for most of the sectors and the department. So it means that Colombia is not relying much on international trade for the water footprint, but it has a problem regarding the allocation of water within its national boundary. And the same with, with Antioquia is another example that is a net, overall is net water importer, but it is a net water importer due to the other departments, because with respect of the rest of the world is a net exporter. While, for instance, Casanare is a net exporter, both in terms of with respect to the other departments and with respect to the rest of the world. So the next step that we are working on is try to connect this kind of information with the socioeconomic side. So we have the same kind of information, so regarding the sectors and the department for several socioeconomic indicators. And it is interesting because, for instance, if we look at the informal labor, these people that don't have a proper contract or a legal contract, and so they work without this kind of contract, are very spread across Colombia, but most of them are concentrated in the sectors that are using most of the water. So this is one possible link regarding the water management and the economic side. So what happens if we want, for instance, to reduce the water because a sector is using too much water, but in that sector there are a lot of people that has informal labor, so that are not protected. So it emerges a problem of social security and the possible trade-off between the water management and the labor sector. And also is very important in this period of post-pandemic, because Colombia is recording a high, I'm going to finish, is going to recording a high number of infections, because most of the people have informal labor, so they can't stay at home. So next step, as I said, we want to extend to other footprint, to the social footprint with new data to implement a temporal analysis and to develop also a dynamic simulation model. And so to evaluate the policies within Colombia. So what we can say is that, first of all, spatial differences are important within the national territory, both in terms of policy and the climate change possible effect. And an holistic approach is necessary to understand the linkages. So these two dimensions are not separated. And so the possible emergencies of synergies and trade-off, also in terms of SDGs, and that there are natural and social limits also in poorest countries. So maybe simply aim at economic growth is not enough. And here is a comic to understand the link. So thanks.
Thank you, Tiziano. We have time for a few questions. Okay, if no one has some question, I wanted to ask you, how your analysis can help, like, in terms of climate change and the future consumption, because probably the population in Colombia is going to increase, and climate change impacts might also impair the water resource. How your analysis can help in this sense, and what do you forecast?
Yeah, thanks for the question. I mean, the idea is that this kind of analysis can help also because one of the things that we're going to do is to evaluate the local water stress. So the departments that are much more under stress and the origin of this stress. So why they are water stress? Because I mean, some of them, from the preliminary results, are under stress because they are selling products to mostly to other departments. So this is important because also we want to integrate this kind of analysis with data regarding the impact of climate change, for instance, from the IPCC at lower scale, and so see if these regions are more affected also by climate change. So this is that might be an issue, and but the most important thing is try to develop a model that, based on input-output, that connect what happens if, for instance, if I change demand, it affects the economic growth, but it affects the use on resources that limits the economic growth. So try to build a feedback loop, and so try to evaluate how endogenously these dimensions integrate, and not by assuming, for instance, an economic growth of 3% and see how much it affected the water or the labor or whatever.